Okay, so in this video, I'm going to show you about lesson 1.7, and the learning target for this lesson is I can solve complex equations involving fractions. So today we're going to go through and we are going to solve equations with fractions. I'm going to show you a couple different methods to do so. So the ones I'm going to do in this video are these problems. I'm going to do 1, 2, and 3, and then I'm going to do 6. So I'm actually just going to do these problems out step by step so you can kind of see where they're coming from. So if you need to look back at anything, they are here for you. You don't have to write anything down. You really just have to listen because these will all be here all the time. So I'm going to open up and I'm going to start with these fractions equations here, the ones that look like this, and they are 1 and 2 in the notes too. So there's a couple different ways you can solve these types of equations, and the first way and the easiest way would be to literally just do the same thing you would do on a typical equation. So maybe you draw your wall and you subtract 2/3 on both sides. And your calculator will actually do this for you. You don't have to really do it in your head, which is nice. Although you probably could do this problem in your head because of the common denominators. So actually you could pull up the calculator and do 7/3 minus 2/3 in your calculator. So to do this though, you're going to need to make sure you really use those parentheses. So 7/3 has to go in its own parentheses, and then if I do 2/3, that has to go in its own parentheses as well. And decimals will certainly do the same thing. So if I do that, I get this long decimal, but I don't want to work with decimals, so I'm going to change it into a fraction. And that fraction is 5/3, which you could probably guess or do in your head. But you could also totally use this calculator for that too. So if I go back to, my live image there, I have 5/3 here now, and then the additive inverse makes that 0. So I'm just left with 5/3 x. Okay, and then my last step to get rid of it is always to divide. So I can divide by a fraction, which is 5/3, and I can be left with x equals whatever. So if I want to go back to this, I can do 5/3 divided by 5/3 in my calculator, although you could probably do that in your head. But again, you just have to use parentheses, especially for something like this, because you're dividing a fraction, which means there's like division all over the place. So you have to do 5/3 in parentheses, then another division sign, and then more parentheses to do the other 5/3. Close that, and then you should be able to do it, and you get 1. So if you go back, your answer is actually just 1 here. Okay, that is one method to solve that problem. The other one, and let me just rewrite it out here, is to use what's called scaling up. So you might have done this before, and we're going to kind of use the properties we've talked about earlier in this unit. But to get rid of a fraction, I can multiply by its inverse. Okay, so if you look, all of these fractions are divisible by 3. So to undo that, I can multiply by 3, which just means I have to multiply everything by 3. And this is where that multiplication property of equality comes in. If I do it to one side, I have to do it to the other. And I have to make sure I do it to everything. Because if you consider something like this, so if I do 5 plus 3 is 8, okay? If I just multiply 5 by 3 and 8 by 3, I get 15 plus 3 equals 24. That is no longer true. To keep that true, I also have to multiply that 3 by 3, so that way it becomes 15 plus 9, which is equal to 24. So using that simple example, you can see that you have to make sure you multiply everything to maintain equality. So if I do that, I get 3 times 5 is 15, and I get 3 times 2 is 6. Keep that same denominator. I'm not messing with that denominator at all. And 7 times 3 is 21 over 3. And then if you look, now this makes it really easy because 15 is divisible by 3. It gives me 5. And 6 is divisible by 3. It gives me 2. And 21 is divisible by 3. It gives me 7. So now it's just a simple equation I know how to solve. I can subtract 2 on both sides. I'm going to come over here. I get 5x equals 5, and I divide by 5, last step, and I get x is equal to 1, which is the same answer I got here. So which proves I can do it either way. Okay, so this is the newer method, but you can totally use your calculator if you feel more comfortable that way. Okay, number two. Number two, if you look, is slightly different because they're not all fractions. Okay, so you can always make any number a fraction, even x, even though we don't know what that number is. I know I can make any number a fraction by putting it over 1. Okay, so now I have denominators 1, 6, and 6. So I have to make all my numerators divisible by 6. So I can actually do that by multiplying the numerators by 6. Okay, the trick with this, and this is where most students make mistakes. When I do this, I have to keep my denominator because I'm not adding or subtracting anything. I'm not even multiplying the denominator by 6. I'm just multiplying the numerator. So 6 times x is 6x. I keep that denominator. 5 times 6 is 30, and there's that negative there. I keep the denominator, and then I'm going to have to do negative 17 times 6 in my calculator. And I get negative 102 over 6. But now that I have it here, I can actually divide everything out. So 6x divided by 1 is just 6x. 30 divided by 6 is minus 5. And negative 102 divided by 6 is just negative 17. Okay, so now it's just a regular equation. It's a simple equation. I can solve this. I can add 5 on both sides. That is the multiplication property of addition property of equality, excuse me. So then additive inverse makes that 0. Negative 17 plus 5 is negative 12. And then I'm going to use the multiplication property of equality now to get x equal to negative 2. And that is my answer. Okay. Another tip, if I'm going to check this in my calculator, remember you can take that negative 2 and plug that in for x and make sure that the equation is true, remains true on both sides. Okay, next example I'm going to look at is example number 3. It looks like this. It says y over 3 minus y over 5 equals 2. So the first thing I'm going to do, because I want to make everything look alike, is make 2 a fraction by putting it over 1. So now I have to make all these fractions divisible by 3, by 5, and by 1. So the easiest way to do that is to find their common multiple. So, for example, 15 is a multiple of 3 and a multiple of 5, and will be divisible by both of those numbers. So if I multiply all my numerators by 15, which is, I know, a big number, my denominators will divide out. So if I do 15 times y, I get 15y. Over 3. Remember, keep that denominator. It doesn't just go away until we simplify. 15 times y is 15y over 5. And then I'm left with 2 times 15, which is 30, over 1. So now I can simplify. 15 divided by 3 is just 5y. Negative 15 over 5 is just 3y. And 30 divided by 1 is just 30. So I can simplify 5 minus 2. These are like terms. Or my 5 minus 3 is 2y equals 30. And again, if you have to, you can build that wall down the middle so you don't combine non-like terms. I divide by 2 on both sides, and y is equal to 15. So that is my answer there. Okay, and then finally I'm going to show you one more. So what happens if you have a mixed fraction? Well, the first thing I'm going to do is change the mixed fraction to an improper fraction. So if you remember how to do that, you take your mixed fraction and you do the denominator times the whole number, which is just 4 times 1 is just 4, and then you add that numerator. So it's really just 5 over 4. That is the mixed fraction of that. So I'm just going to rewrite this and replacing that mixed fraction with an improper fraction. Okay, awesome. So then if I were to go, I can do this by my calculator, or I can look for a common multiple, so I can divide out 6 and 4. So 4 and 6 both go into 12, so I'm going to actually use 12 as my multiple, so that way I can divide out those denominators. So 7 times 12 is 84, so I have 84 over 4 is equal to 12x over 6, and 5 times 12 is 60, 60 over 4. And now everything's divisible, so I can go ahead and start dividing to get rid of those fractions. 84 divided by 4 is 21. 12 divided by 6 is 2x. And 60 divided by 4 is 15. And now I have just a simple equation I can solve. I can use addition property of equality there. 21 minus 15 is 6. And then I can finally use a multiplication property of equality to get x equals 3. Okay, and then I can go ahead and check my answer by plugging that x back in for x there and solving. Okay, so that's how to deal with different type of fractions when you have denominators that are the same, such as number 1, or denominators that are different, such as number 3 and 4, or 3 and 6, I'm sorry. So those are a bunch of different ways. If you're one of those people who wants to use it this way, just make sure you're using parentheses in your calculator. That is super important. Otherwise, you might get wrong answers and your calculator won't read it correctly. Okay, thanks for watching.